Welcome to SysEng Quick. My name is John, and today I'm going to teach you about YAML files. YAML is similar to other file formats such as INI, JSON, TOML, and XML, but is designed to be more human readable. This has made it incredibly popular for configuration files or as a set of instructions to use with tools such as Ansible and Kubernetes. JSON is more efficient than YAML, but it's less expressive. XML is more extensible, but is harder to read and process. TOML is the most similar in terms of use case, but has a wholly different approach to defining the structure. There is no perfect language for every use case, which is why there are so many. But YAML is always my first choice, as I think it strikes the best balance between readability and expressiveness. That being said, I've seen a number of people struggle with it, and it takes time and effort to learn all the nuances. Let's get started. Let's make our first YAML file. YAML files can end in .yml or .yaml. I prefer the .yaml extension most of the time, but I do use .yml with Ansible files. This is so VS Code can treat them specially and do extra linting on Ansible-specific YAML files. But for most purposes, it won't matter which one you pick. YAML files contain one or more YAML documents. A document contains the data you are storing and can be a scalar, a mapping, or a sequence. We'll talk more about those types later. I'm going to start with 3 dashes. This is the document boundary and indicates that a new document will begin after this line. You only need the boundary if you have multiple documents or YAML directives, but I prefer to add them to every file, even when they're not strictly necessary. We mentioned types earlier, the first one being a scalar. A scalar is a simple value, such as a string, number, or Boolean. There are other types, but these are the most common. Let's create a scalar document with a string value. And there we go. We have our first YAML document, which encodes this string into a single document. Not the most useful document, but it is our first YAML document. You probably won't run into too many scalar documents in YAML, but they are valid and have their uses. The most common type of document is a mapping. The default mapping doc is a key value store similar to a Python dictionary or JavaScript objects. I've made a new file, so2.yaml. Let's make a new mapping doc here. Every entry in our map must be on its own line. First, enter the key, followed by a colon, and then the value. Notice that we put a space between the colon and value. YAML has a lot of rules about spacing, and this is the first. Without that space, it isn't valid YAML. Let's add some more key value pairs. Keys must be unique in mapping docs. If I try to define this key to be something else, you'll see that the YAML extension in VS Code warns me that map keys must be unique. Now, certain parsers will go ahead and work with this, but their behavior is undefined. So it's always best to make sure that you don't have duplicate keys in your YAML mapping document. YAML is designed to be human readable, so most values are written exactly as you would expect. If we create a new key, stir, and give it a value, string value, YAML will know this is a string, and we don't need any quotes. I can make another key, num, and give it a value 42, and YAML will automatically interpret this as an integer. I'll add a third key, bool, with a value of true. Again, YAML knows this is a Boolean, not the literal value true. If you want the literal value true, you can quote it to get the string true. We've been using scalar values, but we can also use mappings. Let's make a new key, map. Just like our original key value pairs, each key value in our new map must be on its own line. For YAML to understand that these belong to the map key's value, we need to indent them. The indentation must be in spaces, in other words, no tabs, and must be the same for each key value pair in the map's value. The most common indentation level is 2 spaces, with 4 also being used. Let's place a few entries into our new map. Keys are only unique to their own map, so it's okay that we duplicated these key names in our map value here. In addition to scalar and mappings, there is one more type of node in YAML, the sequence. A sequence is an ordered collection of elements, like a list or an array. We can add sequences as values, just as we can for scalar and mapping types. Let's add a new key, seq, with a sequence value. Every element in a sequence begins with a dash and a space. Although you don't have to indent sequence elements like you do with mappings, I think it looks odd when you don't, and the formatter I use will change this automatically. In YAML 1.1, the scalar values true, false, on, off, yes, and no, either fully lowercase, uppercase, or with the first letter in uppercase, are interpreted as Booleans. This led to significant confusion, so in YAML 1.2, only true and false are treated as Booleans. As of June 2024, YAML 1.2 is nearly 15 years old, but there are still major projects using YAML 1.1 parsers, including Ansible. To avoid ambiguity, I recommend using all lowercase true and false for Boolean values, and quote any use of the words true, false, yes, no, on, and off if you want the string values. If we use YQ, you can see that it's doing 1.2 rules. Only the first 2 are treated as Booleans. But if we use PyYAML, you can see that's 1.1, and all of them are interpreted as Boolean values. We saw the use of a sequence in a mapping key value, but sequences can also be used as root YAML documents. On the right, I've used YQ to transform the YAML document to JSON, which shows the document as a JSON array. In a mapping, we've seen that key values can be scalars, other mappings, and sequences. The same can be applied to the values of sequences. We've used scalars so far, but we can use mappings or even other sequences as values. I've placed a second document in our YAML file by using a document boundary. Some applications, like Puppet Hira files, only allow a single YAML document, but Kubernetes commonly makes use of multiple documents in manifest files. Our second document is a sequence of mappings. Each mapping has a fruit and a color. We can see the JSON interpretation given by YQ on the right. I've added a third document. This one is a sequence of sequences. The first element starts on line 18. We have the familiar dash space. Then, to create the sequence value, we add another dash and a space, and then the value for that sequence. Our root sequence's first value is the sequence alpha, beta, gamma, delta. On line 22, we add the second value. You can see we used a new line here and indented rather than used a space. Both work, but I find the latter more readable. We'll see other ways of using sequences and mappings later. On the right, you can see the JSON interpretation. In this file, we've got some new elements. Line 3 shows our first comment. To add a comment, simply add an octothorpe, aka hash, pound, number, or sharp symbol. Anything after this symbol is treated as a comment and ignored. You can see the results when we transform the document into JSON on the right, which doesn't support comments. Comments are a handy way of making notes within your document, and one reason to prefer YAML over JSON for configuration files where parsing speed isn't the most important concern. Starting on line 7, we see that sequence of Booleans from earlier, but there's something new on lines 9 and 13. These are explicit type specifiers. They tell the parser not to guess at the type, but interpret it based on the value we supply. In the JSON output on the right, you can see the scalar false, which would normally be interpreted as a Boolean, is actually a string value. And the no value, which in YAML 1.2 should be a string, is being treated as a Boolean false. Let's go back to line 1, where I added our first directive. Directives tell the parser how to interpret the file. Most of the time, they aren't needed, and some parsers don't always make full use of them. The YAML directive tells the parser which version of YAML we're using. This should mean that all of our on-off and yes-no values are treated as Booleans. But as you can see on the right, YQ's parser doesn't do this. However, the parser in YAML does. Directives must be placed before the document boundary, as they are just a note to the parser on how to interpret the file. Let's talk about the various ways you can work with strings in YAML. This part will get a little complicated, so you might want to go grab a drink. YAML works to balance expressiveness and readability. Getting the exact output you want might take a few tries, but YAML can encode any kind of string if you format it properly. In this document, I have a sequence of string values. The first element is the most basic, an unquoted string. Almost any scalar with printable characters that isn't clearly a number is treated as a string. Most of the time, strings don't need quotes, but you can quote them if you want, as seen on line 3. Long strings can be hard to read. Starting on line 4, you can see that we can break up long strings across multiple lines, so long as you indent the subsequent lines. The line breaks are treated as space characters. Starting on line 7, we can see that you can add line breaks if you double them. This can get really confusing, as this 7-line block will end up a 3-line string. There are better ways to add line breaks, so don't do this. Line 15 can be very helpful. Sometimes you want to break up a string for readability, but you cannot have white space in between. You can achieve this by quoting the string and adding a backslash at the end of the line where you want to break. This essentially escapes the new line. Let's see how these YAML strings are interpreted in JSON. You can see our first string is just a string. Pretty basic. Our string with quotes is just the same as one without quotes. Here's our multi-line string, but you can see there's no line breaks. It's just a space between all of our line. This next one is where we added the line breaks. Again, I don't recommend this, but it does work. So here's the first line, the new line break, our second line, the second line break, and our third line. Again, that's just confusing. That 7-line stanza is a 3-line string. Don't use it. The final one is useful though. In case you want to break up a long line, but you can't have the space, just use quotes and add a backslash. You can see that we broke the string on the word space, but there's no space in space. I hope you grabbed that drink. There's a lot more to cover. In this document, our first element contains a string that has a quoted value. The parser can't distinguish between a string where the first word is quoted and the start of a quoted string. If your first character is a literal quote mark, your entire string must be quoted. You can see the difference on line 3. The apostrophe in the word "I'd" doesn't require us to quote the entire string. The parser understands this is just a character inside the string. On line 4, we've used an escape sequence to put a double quote inside a double quoted string. There are many useful escape sequences, like \n for new lines or \t for tab characters. If you need a literal backslash or double quote, you'll need to add a backslash to escape them first. Line 5 shows us that we may have been overthinking line 4 a bit. Line 6 shows us a single quoted string. Single quoted strings do not use escape sequences, so they can be easier to read in some places. If you need a literal single quote in a single quoted string, just double the quote. Starting on line 7, we have a folded string. These are very similar to our first multi-line string, where it treats new lines as spaces. The difference is in how the final new lines are treated. If you want a new line at the end of the string, or maybe even more than one, you need to use a folded string. In line 11, you can see we add the chomp operator to remove that final line break, though if you want that, it's probably easier to just use the normal multi-line syntax, which behaves the same way. On line 13, we have a literal string block. Literal string blocks treat strings exactly as they're written, but they remove the required YAML indentation. So here we have a 3-line string written in 3 lines, with a line break at the very end. Just as on line 11, we can add the strip chomp operator if you want to remove the final line break. Let's take a look at the JSON output. Over here, you can see here's our quoted string. It looks just fine. Again, we used "'id" here. Didn't have to quote this one because the apostrophe didn't come first. Here we use the escape sequence to get our double quotes, and because we have JSON, we do the same thing. We didn't have to in YAML because we didn't quote the string, but JSON does it for us. Over here is our single quoted string, and again, the apostrophe was not doubled. That was a YAML thing to make sure we could add this apostrophe inside our single quoted string. Here's our folded string, just like our multi-line string, but it includes a new line at the very end. And if we don't want that, we could add the chomp operator. Our literal string block has our new lines, 1, 2, 3. Literally 3 strings in 3 lines. Finally, we have the chomp operator to remove the final line break. Let's see if we can wrap this up. On line 2, we have the keep chomp operator. This allows you to have multiple new lines at the end of your string. It works for both folded and literal string blocks. This string folds these first 3 lines, and then it adds 3 new lines at the end. 1 for the end of the block, and 2 more for these new lines at the end. On line 8, we have the indentation indicator. If you want the first line of your block to be indented, you need to tell it how many spaces to interpret as YAML indentation and how many are literal. Here we're using 2 spaces for YAML indentation. So if a line has more than 2 spaces, the rest of the spaces are part of the string. Lines 1 and 3 are indented by 2 spaces, but the second line is not. If your first line is not indented, you don't need the indentation indicator. Subsequent lines with extra indentation will be understood to be part of the string. The last string shows us the versatility of double quoted strings. If you need something really complicated, you might have to sacrifice readability to get it. This first backslash removes the space we would have had at the start by placing the start of the string on the new line. The \n gives us a literal new line, and then this backslash keeps us from having a space before this next line on 14. We can use the backslash to keep indentation as seen on line 19. Finally, a reminder that blank lines are treated as new lines. Let's see how it looks in JSON. So here we go with that first block. Our strings got folded, and we have 3 new lines at the end. For our second block, we've got indentation on the first and third line, but not the second line. Finally, we have this complicated string. You can see we had that new line before double quoted, but we didn't add that space in here. We have our new line, again with no space, and then we do have indentation on line 19, which is right here. And then we have all of those blank lines that gave us line breaks. But most of these are just folded. Okay, that's enough about strings. Let's touch on YAML Anchors next. Anchors let you mark values, and rather than copying them, you can simply reference them. This can be useful if you need the same value in multiple places, or if you want to define a value where it's easy to see and change and reference it later. In this document, we have a key, Systems, which has entries for two Linux distros, Ubuntu Noble Numbat and Debian Bookworm. Before we define their value, we have a couple of odd symbols. These are the anchors. To declare an anchor, you place an ampersand followed by a scalar which names the anchor. Any YAML scalar value should be valid. The anchor is a reference to the value. So the Bookworm anchor references the mapping with the name Debian and the version 12, and the Noble anchor references this mapping with the name Ubuntu and the version 2404. When you want to reference an anchor, place an asterisk followed by the name of the anchor. The value will be the same as the value where the anchor is defined. Let's take a look at the JSON and see how this stacks up. We can see we've got our systems, we've got our Bookworm and Noble system, but the Debian and Ubuntu have the same value as the Ubuntu version above and the Debian version before that. So our anchors let us reference those values and not repeat them. In this document, we created a key, Anchors, which is a sequence of anchors. Anchors can reference any YAML value, so if you don't need a named key, a sequence is a good alternative. In the API endpoints mapping, we define some zones, which each have a name and a URL, and a special key known as the merge key. The merge key allows us to combine our values with a referenced mapping. In Zone 1 and Zone 2, we merge the API creds mapping with our name and URL properties. In Zone 3, we merged our mapping with the mapping from API creds. This is an important distinction because the order matters. Let's check out the JSON to see how. You can see we have our API endpoints, and our merge token has seen to it that the token is in every one of our zones. However, our URL properties for Zone 1 and Zone 2 are exactly how we define them in those mappings. But in Zone 3, the URL is the same URL from our API creds anchor. Later values overwrite earlier ones. So even though we defined URL with Zone 3, we took the value from API creds because we merged that afterwards. In most cases, you'll probably want your merge key to come first, and I hope this illustrates a good reason why. Let's wrap up with a few miscellaneous items. First, YAML is a JSON superset. This means all valid JSON documents are also valid YAML documents. YAML 1.1 has some edge cases, but you're unlikely to run into any problems. I wouldn't recommend writing JSON documents in YAML, but there are probably machine interaction cases that could make this useful at times. Leave me a comment if you have an actual use case for this. JSON compatibility is more often used with flow syntax, which is quite similar to JSON, but more flexible. For instance, with flow syntax, you retain the YAML scalar quoting rules. The first document in this file is an object with three keys, a string, a floating point, and a null value. The second document is an array with two strings. The third document contains some useful values you may need. YAML treats the empty value as an implicit null. However, I prefer the explicit null, where you place a tilde as the value. This makes it clear you didn't just forget to put a value somewhere. If you want an empty string, simply put quotes around nothing. For an empty map, use the opening and closing curly brackets. For a sequence that's empty, use open and closing square brackets. Here we show off the flow syntax for mappings and sequences, but you can see, unlike JSON, we retain the YAML scalar quoting rules. We didn't have to quote any of these values, though we could have if we wanted. This last document is a scalar. We declare it to explicitly be a string value, and it's a literal block that keeps all new lines. To make sure it's clear how many new lines, we use the end of document marker, which is an ellipsis. So this string will have 1, 2, 3 new lines at the end. Let's take a look at the JSON to see how it translates. Yes, the first document is an object. The second is a sequence of 2 string values. The third one is showing off all of those special values and the flow syntax. The final document is our literal string, and it does have 1, 2, and 3 new lines at the end. Yes, this all looks pretty good. I think that covers everything you'd need to know about YAML. YAML is my favorite data serialization language. TOML is nice too, but I find YAML syntax more readable, and it's far more practical than JSON or XML for config files, in my opinion. I hope you found today's video helpful. If you did, please hit those like and subscribe buttons. If you have questions or concerns, leave me a comment. The idea for this video came from a comment from AnonNB4BB. I hope it's what you were looking for, and sorry if I butchered your name. Thanks for watching. See you next time.